I've tried a few times already this weekend, and this is the first time that hopefully the whole thing works. So here we go. Let's go ahead and look at this first one here. We're asked to find a rule for the following input-output table. And so I'm looking at these things, and I'm trying to think about how this shape might give this output. And that's kind of an interesting puzzle. I'm going to zoom in here and really look at it. One of the things I can notice about a shape is the number of sides. So I'm going to notice that this triangle has 1, 2, 3 sides. And since there's 3 sides on it, I'm going to try to think about how that might relate to the fact that there's 29 for the output. I don't quite know yet, so I'm going to keep looking. This one has 4 sides, and it has 39 as an output. And then this shape, I'm going to zoom in and count here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sides. So I've got 12 sides, and that gives 119. And I'm noticing something. I'm kind of thinking about how companies will charge you like $3.99 when they really are actually charging you $4. And they try to charge you $3.99 because it seems like it's cheaper. When I look at 29, that is almost 30, and 39 is almost 40, and 119 is almost 120, and now I start seeing kind of a relationship here. I know that I can take 3 times 10 and get 30, and I can take 4 times 10 and get 40, and 12 times 10 and get 120. And so there's something interesting going on here. So I can almost get the right number if I multiply the number of sides by 10. And it seems like all I have to do is sort of maybe take away 1. If I do 3 times 10 minus 1, that gives me 30 minus 1, and that gives me 29. If I take away 1 from 4 times 10 minus 1, that gives me 40 minus 1 is 39. So it seems like it's working a little bit here. 12 times 12 minus 1. Oh, 12 times 10. I miswrote it there. Whoops. Sorry about that. Times 10 minus 1. That gives me 120 minus 1, which is 119. And so these are all working according to my thinking here. Let's test on the other one. So there's 6 sides here, times 10 minus 1. So that's 60 minus 1 equals 59. And that one works. This circle doesn't have any sides, so it's kind of like question times 10 minus 1. So that kind of works, I guess. Here's 4 times 10 minus 1 again, and that does give me 39 because it worked for this shape up here. So it looks like my rule has to be number of sides on input shape, all of that times 10 minus 1 equals output. And you'll notice here, I'm going to do some highlighting, that my times 10 was in every single one of my pieces of work here. My minus 1 was in every single piece of my work here. And so then the only things that I needed to change were the number of sides and the outputs, and that's why those took those places there. All right, explain why it is not possible to find a rule for the following table. Okay, so they're telling us there's no rule for this table. And I'm going to try to kind of think about it here for a minute. So -2, I'm just going to brainstorm. I can take -2 times -2 and get +4. And so maybe the rule is times -2. And so that seems like it might work, especially if I think of it as -2 times -2 equals 4, 3 times itself equals 9. So -2 times itself equals 4. 3 times itself equals 9. 6 times itself equals 36. It's looking good, but then I hit this -2 again. That's kind of weird because -2 times, if I follow the same pattern, there's no way I'll get to 9. So I think maybe the key is right there and right there. -2, if you try to do something to -2 to get 4, you can't do the same thing to -2 and get 9. So that's what I'm going to write. If you do something to -2 to get +4, you can't do that same thing and get negative or positive 9. Cool. So there are some input-output tables that cannot have a rule written for them. And this one is actually called a relation, but it's not a function. And we're going to talk more about that later this year. This one where you can write a rule is called a function. All right. Because there's only one row in each table of the following tables, it is possible to come up with many possible input-output rules. For each table, state 3 possible input-output rules. Your rules should use the words input and output. So I get to play the game of how do I get from -3 to 2? And I'm going to say, well, I'm going to do my work over here, and I'm going to put my rules over here. Okay, so my work, I'm going to think, well, make my pen a little smaller here. -3 plus 5 equals 2. I could do -3 times -3 minus 4, because that's 9 minus 4. Well, that doesn't work. How about 9 minus 7? Because that equals 2. And then I could do -3 times -2 and take away 1, because -3 times -2 is 6 minus, and I'll take away 4 to get back to 2. And so if I think about these 3 examples here that I've got, I can write input-output rules for them. So the rule might be that you take the input plus 5 to get the output. You could, that's this one, you could take the input times itself, that's what squared means, minus 7 to get the output. You could take the input times -2 minus 4 to get the output. Any of those would work here. All right, so let's try this with the next one. I'm going to do the same kind of thing, and I'll write in a different color to distinguish it. Let's put the work over here, and we'll put our rules over here. And so I need to do -1. I'm going to do straight subtraction here. -4 equals -5. So that's my first one. I'm going to go straight to the rule here. I'm going to take input. That means you could take input minus 4 equals output. Okay, how about -1 times -5? Oh, there's a problem there because a negative times a negative is a positive. What if I did -1 times +5? Yeah, negative times a positive is a negative, so that's -5. So that's input in pup. Obviously, I'm fading here pretty fast. I'm kind of tired, folks. Times 5 equals output. We could do, let's think of another one. -1 times, I'm just going to multiply it by 4 this time, because that will give -4, and I could take away 1 more to get to -5. So input times -4, oh, not -4, +4. Input times 4 minus 1 equals our, output. All right, so we have 3 possible rules there. So let's take a look at this last one. Let's see. Let's do some work over here and my rules over here again. How about -1 times, and I need to make it a positive, so -2 equals +2. So that could be input times -2 equals output. And I could do, let's see, -1 plus 3 equals 2. So that's input plus 3 equals output. And then finally, let's see, let's just get weird. Let's do -1 squared. That's -1 times -1. That makes +1. And then add 1 to it. and that equals 2. So that would be input squared plus 1 equals output. Because negative 1 times negative 1 is 1 plus 1 equals 2. All right. So this is meant to help you practice just guessing what the rule is, because right now the way that we find the rule for an input-output table is to just guess and check. You look at stuff, you do some reasoning, you think about it, and then you try to figure out what the heck's going on. So that's what we've done so far. We've made some guesses, and now these next problems, you might notice that 3 and negative 2 show up right there. Negative 1 and negative 5 show up right there, and negative 1 and 2 show up right here. So what they're asking us to do on this next set of problems is to see if any of our rules work, and if they don't, come up with the rule that works. So let's check our rules. So I'm going to check this first rule here. I'll get rid of this highlighting. I'm going to check this rule, input plus 5 equals output. So it should be plus 5, and that does equal 4. 0 plus 5 equals 5. 2 plus 5 equals 7. 3 plus 5 equals 8, and it looks like I'm in the money here. So my first rule that I guessed is totally right. It is input plus 5 equals output, because it works for every row in the table. And so if it's going to be a rule, it has to work for every row in the table. All right, so let's try this rule. Input minus 4 equals output. So I know it works for negative 1 and negative 5. I'll try 0. Whoops. 0 minus 4 does not equal negative 1, so that can't be the rule. So I'm gonna kind of put a line through this one here. So that can't be the rule. Let's try the next one. I'll do this one in red. Input times 5 equals negative 5, or equals the output. So 0 times 5, oh man, that does not equal negative 1. So the second one cannot be the rule, because it doesn't work for every row in the table. In fact, it doesn't work for 2 rows in the table. Let's do the last one. We'll use blue here, just because we have these crazy zany tools. Input times 4 minus 1. So how about times 4 minus 1 equals negative 5. Times 4, 0 times 4 is 0. Minus 1 equals negative 1. So hey, it works there. 1 times 4 is 4. Minus 1 gives you 3. We're looking good here. Times 4, 2 times 4 is 8. Minus 1 gives you 7. And 3 times 4 minus 1 equals 11. All right, so we found the rule here. It's input times 4 minus 1 equals output. Not too shabby. Let's figure out this last one here. We'll start with the top one. Input minus times negative 2 equals output. Let's test it. So 2 times negative 2 does not equal 8. So we're in bad shape there. The first one does not work. So let's try another one. Input plus 3 equals output. Negative 2 plus 3 equals 1. It does not equal 8. So we got a problem there. It does not work for that one. All right, so let's try input squared plus 1 equals output. So negative 2 times negative 2, that would be positive 4, plus 1. Oh man, that's only 5, so that doesn't work either. So none of the rules we came up with seem to work. Bummer. Super bummer. So we got to go back to the drawing board and see if we can figure anything out for this last one. Let's see here. I'm going to go back to black ink. Let's try, I think we should go to the 0 column. And the reason I think we should go there is that you can't go from 0 to 0 by adding or subtracting anything. So I don't think there is any addition or subtraction. No adding or subtracting in rule, because the only way to go from 0 to 0 is by not adding or subtracting. You can only multiply or divide. Sorry, multiply or square or something like that. So something that I'm noticing is that 8 and 8 are on here, and 2 and 2 are on here. And so I'm wondering about that. It kind of is a little bit curious. It makes me think. It makes me think that negative 2 and 2, since they have to come out with the same thing, it's like it doesn't matter that it's positive or negative. And I'm thinking they're both like 8 and 8 are both positive. So I don't know. Let's try another squaring rule. Because 2 times 2 is 4. And I know I can't just add 1. There's no adding or subtracting. So 2 times 2 is 4. What if I were to multiply it by another 2? Because 2 times 2 times 2 is 8. So that works there. Let's try it here. 2 times 1 times itself. 1 times itself is 1. Times 2 is 2. So it seems like it's working. 0 times 0 is 0. Times 2 is 0 again. So I might be onto something here. Negative 1 times negative 1. Negative and a negative times each other make a positive. So that's positive 1 times 2 is positive 2. And negative 2 times negative 2 is positive 4. And then positive 4 times 2 again is 8. And so notice that. I noticed that there's 8 and 8 here and 2 here. And that told me that perhaps there was something going on where it had to be multiplied by itself, because it seemed like the negatives didn't matter. And when you square stuff, everything turns out positive. So that's a way of saying that the negatives don't really matter. So I think my rule then is 2 times the input squared equals the output. Hooray. So is that the end of the first page? All right, great. Let's look at the back page now. Staying sharp. So these square box problems, you got to add up to make the bottom, times to make the top. So 2 plus something equals negative 9. And so that has to be a big negative number, a negative number that's bigger than 2 because it ends up at negative 9. So I think it's probably going to be negative 11, because negative 11 plus 2 equals negative 9. And then we just have to do negative 11 times 2 equals negative 22. We're in good shape there. Let's keep moving. 5n minus 2 is our rule up here. I'm going to highlight it. We need to use it to complete the table. So this is going to be 5 times 1 minus 2. 5 times 1 is 5, minus 2 equals 3. So that's 3. I'm going to have to work a little smaller here. Let's try another one. 5 times 4 minus 2. So 5 times 4 is 20, minus 2 equals 18. So that's 18. Let's skip those two because I like using this stuff first. So let's try 5 times 20 minus 2 equals, 5 times 20 is 100, minus 2 is 98. So that's got to be 98 there. So let's think about these two, because they're asking us something a little bit different. They're giving us the output number and asking us for the input number. And so what I'm thinking about is that for these two, we multiplied times 5, and then we subtracted 2. And so I wonder if we have to kind of work backwards like that token problem. And I'll do these in two different ways. So one of the things you could do is, since we want to work backwards, we know that at the starting point, you started with a number, it times 5, and you subtracted 2, and then you ended up with negative 33. And so we kind of have to do the opposite. I'm going to do 33 plus 2 is 35, because adding 2 is the opposite of subtracting 2. And then I'm going to take 35 and divide by 5, because that's the opposite of timesing by 5, and I get 7. So that's one way to think about it, and that may be a little bit confusing. That's okay, we'll get better at this stuff. But here's another way of thinking about it. I need to do something like 5 times something minus 2 equals 48. And so if I think about that, I know that 50 minus 2 equals 48. That's pretty easy to see. And so 5 times something has to be 50. And the only thing that you can multiply 5 by to get 50 is, and I'll write this in another color, 10. And so you have to multiply by 10. So this has to be 10 right here. So you can work backwards, or you can kind of think through it a little bit and just do a little bit of puzzle solving. But that's how you should fill out that table. We're going to do a lot more of that kind of work in the future. All right, let n represent the row number in this pattern. Write a rule that tells you the number of dots D in a row n. Hint, your rule should begin with D equals. Okay, so I remember doing this in some Math 8. So let's think. Row 1 has 2 dots. Row 2, I see 4 dots. Row 3, I see 1, 2, 3, 4, 5, 6 dots. And row 4 I see looks like 8 dots. And so it seems like it's going up by 2 every time. But really what I need to do is I need to think of this as an input and an output. So 1 is my input, because that's the row number. My output is the number of dots. And so how do I go from 1 to 2? Well, I could multiply by 2. Let's see if that works every time. 2 times 2 is 4, so it's working there. 3 times 2 is 6, so it works there. 4 times 2 is 8. All right, so and really all I'm thinking about here is that my output is the number of dots, D, and my input is the number of rows, N. I'm getting that information from right here. And so it looks like I have to take N times 2, and I get the output D. Looking pretty solid. All right, let's keep moving. Describe the relationship represented by the table. Write your description in a complete sentence. Total cost for rental, hours rented, so those are an important piece of information. It looks like even if you rent it for 0 hours, you still have to pay $40. So I'm going to write that down right away. And usually the way we talk about that is it's kind of like a rental fee or a fee. Here, I'll phrase it like this since we're supposed to write in a complete sentence. A fee of $40 is charged. Then, let's see, every hour that goes by, it adds 12 there, it adds 12 there, and it adds 12 there. So then the company, because I think we're talking about a company since we're renting here, charges $12 per hour. All right, that kind of makes sense because it charges 40 and then 12 and then 12 and then 12. All right, we're going to get really good at writing those rules later too. So if that's still a little confusing, totally fine. So here's what I advise you to do for this problem. Since this is getting you to practice mental math, I advise you to pause the video right after this sentence so that you can try all these problems and then just check your work against mine, okay? All right. Hopefully I can welcome you back right now. 6 times negative 11. Positive times a negative is a negative. 6 times 11 is 66. All right, negative 2 times negative 15. Negative 2, negative and negative make a positive. 2 times 15 is 30. All right, negative divided by a negative makes a positive. 12 divided by 4 is 3. All right, 11 minus 12, it passes 0 to get to negative 1. Negative times a positive is a negative. 8 times 9 is 72. Positive divided by a negative is a negative. 36 divided by 12 is 3. Negative 5 minus 6 will be a larger negative number because we're getting farther into the negatives by subtracting, so that's negative 11. Negative 20 plus negative 10 is going to get farther into the negatives again. That's negative 30. Negative times a positive is a negative. 30 times 3 is 90. Negative 7 plus 40 is going to be just like 40 minus 7, and so that's 33. Okay, let's draw some conclusions. Consider what you know about multiplication of signed numbers. Signed just means plus and positive and negative, which those aren't the symbols for that because I can barely write right now. Whoops, it's getting worse, folks. Positive and negative. There we go. Then complete the following statements and answer the following question. Product of two positive numbers is positive. I like to think of that in sort of a troll's voice. Positive. The product of a positive and negative number is negative. It's getting weird. Negative. It's getting strange, folks. Sorry. Negative. What is the relationship between the product A times B and the product A times B negative B? Hey, those are opposites because one's positive and one's negative. And that's today's homework. Sorry it took me so long to get this posted. I promise I tried 3 different times. So I hope you can forgive me. I'll see you guys tomorrow morning.